Have you ever browsed through a decently maintained C++ GitHub repository and immediately thought to yourself, what kind of hieroglyphic alien tech is this? If yes, you might have come across function calls like this, and maybe you wonder how on earth can someone pass sheer endless flags into only one parameter. Well, so did I, and instead of being reasonable and just looking it up, I was racking my brain about it, and after some months I must have had some sort of divine intervention, a vision from beyond him freaking self, because from one moment to the other it came to me out of the blue. To make this work, we need binary operators, so I checked if Godot supports those, and actually I don't know why this surprised me, but they are indeed supported. For those who don't know, binary operators are operators which work on the bit level. So let's take an integer for example. In Godot an integer is 64-bit long, so we can store anything from 64 zeros to 64 ones in an integer type. 2 to the power of 64 is about 18 quintillion, but the maximum value for integer is at about 9.2 quintillion. This is because one bit is reserved to store whether the number is positive or negative, hence why the value range is shifted down by 9.2 quintillion, but we still have 18 quintillion different values we can store, from this number to this one. But back to binary operators. Those doubled more than and less than signs are used to shift all bits from a value to the left or right, discarding everything that leaves the range. So 8 for example is represented this way in binary, and keep in mind that 8 is of type integer, so it is 64-bit long, but in this video I obviously will not write all 64 numbers every time I use a number. If we bit shift this to the left by 1, we move every bit to the left by 1 spot and fill with zeros on the other side, so we effectively multiplied by 2, and moving to the right by 1 is a division by 2. Relevant for us though are only the logical OR and logical AND operators. The logical OR of two numbers is another number which has a 1 on every location where at least one of the input numbers has a 1. So the logical OR of those numbers is the following. True and true is true, true and false is true, false and true is true, true and false is true, false and true is true, true and false is true, false and true is true, false and true is true, true and true is true, false and false is false, true and false is true, false and true is true, false and true is true, true and false is true, false and false remains false. And even though I said AND, this is how you calculate the logical OR between two numbers. Of course, we do not write in binary, but rather in decimal. So if we convert those same numbers to base 10, we get 9515, logical OR 6613 is 15871. Now to the logical AND, but this time I will use a shorter number to save myself some work, but the principle is obviously still the same. This time we do not write a 1 if at least one number from the input numbers are 1. We write 1 if both input numbers at the same spot are 1. 0 and 1 is 0, 1 and 1 is 1, 1 and 0 is 0, 0 and 0 is 0, 1 and 1 is 1. If we convert this back to decimal numbers, we get 22, logical AND 19 is 18. Now on how we can use this to our advantage. First of all, we need to define an enum. It doesn't matter if you make a named or unnamed enum, because enums are nothing other than integer numbers written as a word, and by default Godot assigns them values beginning from 0 in steps of 1 until the last element. Those numbers in binary look like this, but this way we cannot properly use them for our case yet, because what we instead need to do is assign them in powers of 2. If we now write this in binary, we get this nice pattern here, and I think you might already see where this is going. For my example, I will show you how to use this within the context of an apply damage function, which I assume is something almost everyone here is familiar with. Obviously you want to pass a damage parameter to this method, but what is important for us is a second parameter which I will call elements that needs to be of type integer, and this one will later store all the flags we pass into this function. Now usually you would have something like health minus equals damage, but more interesting is what we do with the elements parameter, which I will only print out for now. Let's call this function in our ready method and call it with, let's say, 100 damage. I will also make a second call and call it with the fire flag set, and unsurprisingly the first call prints 0, which is the default value I set for the elements parameter, and the second call prints 1, which is the value of fire. Trying this with the air flag will obviously result in the method printing out 8, as we can see. So far so good. Someone might get the idea to pass in multiple parameters separated by a comma, which will give you an error because our applied damage function only takes at max 2 parameters. The good thing is we don't have to stupidly extend the quantity of parameters in the function definition, because we can pass in our element flags connected by a logical OR, but more on that later. First I want to show you how we are going to read our flags from just the elements parameter by typing out this little magic. I will explain what I wrote here with an example. Let's say we call this method with only air set. 8 will be copied into the function, so elements has the value 8, which in binary is this number right here. We then perform the logical AND with the enum fire, which basically means 8 logical AND 1, which results to 0. And since 0 is not equal to our fire or 1, we haven't detected the fire flag. If I call it with fire, then elements has the value 1, and if we perform the logical AND between elements and fire, we get the value 1, which is equal to fire, so we have just detected the fire flag being set. I quickly add the checks for all the other elements we have defined in our enum, and now I can show you how we pass multiple flags into elements, because all you have to do is to separate them with the logical OR operator. The following will happen when we reach this line in our code. 8 is being logical ORed with 1, and the result 9 is being logical ORed with 4, which is 13. That means when applied damage is called, the value 13 will be copied into our elements variable, where we perform our checks with it. 13 logical AND 1 is 1, which is equal to fire, so we print out fire. 13 logical AND 2 is 0, which is not equal to water, so we don't print anything here. 13 logical AND 4 is 4, which is equal to earth, so we print out earth. 13 logical AND 8 is 8, which is equal to air, so we print out air. And I only just now came to the realization that we can actually shorten this statement to this. Instead of comparing with the elements, we can just leave the logical AND alone, so in the case of fire being passed in, the evaluation results in 1, and since the if expects a boolean, the 1 is implicitly converted to a bool, which is true. In fact, every number that is not 0 will become true if being converted to a boolean value, and since the logical AND will evaluate to 0 when the corresponding flag is not set, our detection is still valid. So now let's ask us the question, why would you want to use this? It is very scalable, you never have to add more parameters to the function in question. Also, just passing a number is very efficient for performance and for memory, because booleans are usually, and I believe also in Godot, stored as bytes, so 8 booleans would use up the same space as an integer value, while with this approach we can cram 64 bools in one integer if I'm not completely mistaken. The most obvious downside is that this theoretically only properly works with booleans and not with more complex types, even though I can still see how someone could come up with bit level shenanigans that I don't even want to get into now. In addition, I want to compare this approach to Bitlytic's approach he explained in this video right here, which is basically using only one parameter in the damage function that gets an object of the custom type called attack passed. And this right there is a great approach. I highly recommend you watch this video, but to summarize some aspects of it, it is a scalable way to wrap many different values and values of different types into only one parameter, which has the advantage that you never have to change the signature of the damage method, and that different implementations of the damage method can access different properties of the parameter object. Let me also add that what we both showed can be used anywhere and is not just limited to damage functions. Even though both our approaches might seem similar at first glance and we both use a damage function to show them, they could not be more different, because I only explained how you can stuff multiple boolean values into an integer via bit manipulation and how to use this as flags. Both approaches we presented work on two whole different layers, and I dare to say that I can prove this by showing you that our approaches can be perfectly combined without stripping away any of the other aspects. Easiest way is to just take the elements parameter of type integer from my applied damage method and to move it into the custom attack type. And boom, you profit from both to the full extent.